Good morning, everybody. In yesterday's class, we were discuss about the electronic configuration of G17 elements. What is electronic configuration of G17 elements? That is NS2NP5. Then after electronic configuration, we studied the atomic and physical properties containing first point, that is 2 marks question. Explain atomic and ionic radii of G17. In this question, 2 points are very important, which are that first, atomic and ionic radii increases down the group, and second, atomic and ionic radii decreases across the period from left to right. After that question, next question, see the ionization enthalpy. Ionization enthalpy of G17 elements. Shortly, it is IE value, ionization enthalpy. What is ionization enthalpy? The amount of energy required to remove electrons from different cells around the nucleus in an atom of element is called as ionization enthalpy. That is simple definition. This definition is already seen in G16 elements of the ionization enthalpy. What? Amount of energy required to remove electrons from different cells around the nucleus in an atom of element is called as ionization enthalpy. So what is the trend of ionization enthalpy in G17 elements? So first of all, the IE value of G17 elements, that is halogens, the IE value of G17 elements decreases down group. Ionization enthalpy value decreases down the group from fluorine to iodine. Why it is decreases? It is due to increase in atomic size or atomic radius. We know from fluorine to iodine, atomic size of that elements, that is radius, can increases. With increase in atomic size, its ionization enthalpy decreases. Then the IE value of halogens, that is G17 elements, increases across the period from left to right. When we move from left to right across the period, then ionization enthalpy values of halogens is increases. It is due to addition of what? The ionization enthalpy value is increases from left to right. It is due to addition of electrons in same cells. In same cells, number of electrons are increases. Therefore, ionization enthalpy values increases across the period from left to right. However, the G16 elements have lower ionization enthalpy. Than G15. See here, ionization enthalpy of G15 is lower than G16 is lower than G15 due to extra stability of half-filled p orbital, extra stability of half-filled p orbitals. Note down. However, the IE of Z16 lower than Z15. Actually, ionization enthalpy increases 13, 14, 15, 16, but the IE value of Z16 is lower than Z15 due to extra stability of half-filled d orbital, extra stability of half-filled d orbital of Z15 elements, So this is ionization enthalpy, but actual values of ionization enthalpies of these elements, see here table, elements, then IE value, elements and IE values. First element, that is fluorine, chlorine, bromine, iodine. The ionization enthalpy of fluorine is 1680, that is 1680 kilojoule per mole ionization enthalpy. Then chlorine 1256, ionization enthalpy of chlorine is 1256, means not less than fluorine. Then 1142, 1142, and last iodine indicates 1008, 1008. This indicates what? The ionization enthalpy decreases down the group from fluorine to iodine. It is due to increase in size. We know the atomic size of fluorine is less than that of chlorine, less than that of bromine. The atomic size increases, then ionization enthalpy decreases. So these are the points which are required for the 2 marks questions. When questions ask for the 2 marks, explain ionization enthalpy of Z17 elements. After the Z17 elements ionization enthalpy, see the next point, that is electronegativity. Electronegativity of halogens, that is G17 elements. Next, third point, that is electronegativity of G17. This question also asks for the 2 marks. Explain electronegativity of G16. We know all the p block elements are the electronegative because all p block elements requires the electrons for the completion of octet, so it can indicate the electronegativity. But what is the actual trend of halogens electronegativity? In halogens, electronegativity decreases down group. What? In halogens, electronegativity decreases down the group, means from fluorine to iodine. Why it is decreases? It is due to increase in atomic size. It is due to increase in atomic size. Atomic size increases. With increase in atomic size, its electronegativity decreases. But across the period, electronegativity increases. When we move from left to right along the period or across the period, then electronegativity value is increases. Why it increases? It is due to increase in atomic number. Atomic number is increases from left to right. Therefore, its electronegativity value also increases. So these 4 points. First, halogens have electronegativity decreases down the group. It is due to increase in atomic size. Then across the period, electronegativity increases. Why? With increase in atomic number. In halogens, fluorine has higher electronegativity than other elements. In halogens, fluorine have a higher electronegativity than other elements. From fluorine to iodine, the fluorine can shows the higher electronegativity. So see the actual electronegativity. Suppose these are the elements and its electronegativity. Elements and electronegativity. Elements: fluorine, chlorine, bromine and iodine. Then see the electronegativity of these elements. The fluorine shows 4 electronegativity. 4. Then chlorine possesses less than that of the fluorine, that is 3.2. Bromine possesses 3. And last, iodine possesses 2.7. And astatine, that is 2.2. 2.2. See again, fluorine have the electronegativity 4 value. Chlorine possesses 3.2. Then bromine 3. Iodine 2.7. And last, astatine 2.2. This table can indicate the electronegativity value decreases with increase in atomic size. But in halogens, fluorine can possess the higher electronegativity value. Fluorine has the higher electronegativity value than that of the other elements. So this is the next question, that is electronegativity of halogens or G17 elements. After that, see the electron gain enthalpy of halogens. Next, fourth question, electron gain enthalpy. Electron gain enthalpy of G17 elements. First of all, see the definition of electron gain enthalpy. What is electron gain enthalpy? The amount of energy or enthalpy required to complete octet of elements is called as electron gain enthalpy. All p block elements have tendency to gain the electron for the completion of octet. For the gaining of that electrons, it requires the enthalpy. So the first point, the amount of energy required to complete octet, amount of energy or enthalpy required to complete octet by gain electron or to gain electron is called as electron gain enthalpy. So what is the electron gain enthalpy of halogens? In G17 elements, electron gain enthalpy in G17 elements, electron gain enthalpy is less. Electron gain enthalpy is less negative down the down the group. When we move from top to bottom, then electron gain enthalpy value is lesser. That is G17 elements becomes electron gain enthalpy is less. It is due to what? Increase in atomic size. It is due to increase in atomic radii. It is due to increase in atomic radii. Next point, in G17, fluorine has in G17 elements. In G17 elements, fluorine has less. Fluorine has less negative. Fluorine has less negative electron gain enthalpy. Electron gain enthalpy than chlorine. In G17 elements, fluorine has less negative electron gain enthalpy than chlorine. It is due to small atomic size. It is due to small atomic size of fluorine. See again this question. Electron gain enthalpy. What is electron gain enthalpy? The amount of enthalpy or energy required to complete octet. By gain of electrons. By gain of electrons. It's called as electron gain enthalpy. Those elements can gain the electron to complete the octet. It requires the enthalpy. That enthalpy is electron gain enthalpy. So what is the trend of electron gain enthalpy in halogens? In halogens or G17 elements, the electron gain enthalpy is less negative down the group. It is due to increase in atomic radii. Next, in G17 elements, fluorine is the topmost element. Fluorine has less negative electron gain enthalpy than chlorine. Why? It is due to small atomic size of fluorine. Fluorine has the small atomic size, therefore its electron gain enthalpy is less negative. Then see suppose these elements and its electron gain enthalpy. Electron gain enthalpy values. First element is the fluorine, chlorine, bromine and iodine. Electron gain enthalpies. Fluorine possesses minus 333 kilojoule per mole. Electron gain enthalpy value of fluorine is minus 333 kilojoule per moles. Then chlorine minus 349 kilojoule. Then bromine 325 electron gain enthalpy, and last minus 296 electron gain enthalpy values. So this table indicates what? The fluorine has minus 333 and chlorine possesses 349. This indicates what? This fluorine has less negative than chlorine. This fluorine is less negative than chlorine. It is due to small atomic size of fluorine. By comparing these two figures, which fluorine has minus 333 and chlorine possess minus 349 kilojoule per mole. These two figures can indicate what? Fluorine has less negative electron gain enthalpy than chlorine. Therefore, due to what? The small atomic size of that fluorine.